Hello everyone and welcome to our YouTube channel. We are working on a series of videos on openmp and this is our 10th video on the series. If you haven't checked out the previous ones, do watch them to get a better idea of openmp and to better understand these videos. Okay, let's get right to the content. And today we'll be discussing barrier construct. So there's not much to define about barrier construct. The name is pretty evident in this case. Barrier construct creates a barrier, and so that what we want to achieve in this is that we want to synchronize all the threads. We do not want one thread to rush ahead of this another. Why is this required? Well, let's say there is some program, some specific program that needs this kind of thing. So it requires the first phase to finish completely before moving on to the second phase. Okay, let's say program A and program B are independent on each other. So the output from A, final output from A needs to be transferred to final output, needs to be transferred to B for the output from B to be correct. In that type of scenarios, barrier can help us achieve that by it will stop the uh, it will stop the threads from moving on to phase 2. It will wait. So let's say thread 0 was faster and finishes phase 1 first, but it cannot start phase 2 unless all the other threads have finished phase 1. So let's see a live demo of it. And this is the program for the barrier. So in the PPT one, and this is it's a little different. If you can spot it, I have just added an int here and removed this section here. That is just because it was causing some errors in the while execution. Nothing serious. Okay, I am currently logged into a HPC Param Rudra, and I am inside the login node of that HPC. And the openmp programs directory. I have loaded a module Intel 1 API compilers for the openmp compiling that we will require in this compilation. So let's start compiling the program. Go openmp underscore barrier.c /f openmp. This is it's a connector that's required to connect my G++ to openmp. The program is compiled. Now let's run the executable. Okay. So how do we know the program has worked? The barrier construct has worked. So if you see, all of these are for phase 1, right? Up until here, it was only phase 1, and phase 2 started after this, and after this there is only phase 2. Now I will show you, if I remove barrier, what type of output I will get. That will give you the best idea of what I'm talking about. Yes, now see, so we have phase 1, phase 1, phase 1. Now suddenly there's a phase 2 here. Then we have phase 1 and phase 2, phase 1, phase 2, phase 1, phase 2. So we do not require these kind of jumble out mess in the output. What we require is the threads to be synchronized. So because like I said in the example, phase 2 requires the final output from phase 1 to give the correct result. In that type of situation, if I have a thread starting phase 2 without phase 1, even before phase 1 is completed, it will lead to an incorrect output. It will lead to an incorrect final answer, which is not desired. So that is it for this video. In the next one, we'll be talking about another construct.
So till then,
See you later.